Dear students, now we are going to discuss about Planck's radiation law. So this equation gives the law for heat radiation, law of heat radiation. Okay, heat radiation. So in the previous video, we have discussed Planck's hypothesis. So based on the hypothesis only, he derived this equation to explain the law of heat radiation. Okay, so what he made the assumptions. So first one is, this is the black body. So the black body consists of large number of oscillating particles, and this oscillating particles creates the radiation. It emits the radiation. Okay, so this radiation is also having the same frequency of the oscillating particles, and then either the black body absorbs or emits, which is in the form of photons, which is equal to E is equal to NH nu. Okay, E is equal to NH nu. So this is what the assumptions made by Planck. By using this hypothesis only, we are going to derive this equation. So first consider the black body, which consists of the n number of oscillating particles. So what is this n represents? N is the number of oscillators. N is the number of oscillators, or total number of oscillators present in the black body. Okay, and then E suffix n. So due to this number of oscillators, the black body will have the total energy. So the total energy is represented by E suffix n. Total energy of n oscillators, total energy of n oscillators, that is, it represents the total energy of the black body, total energy of the black body, right? So first you have to understand n is the number of oscillators in the black body, and En is the total energy of n oscillators. Okay, and then how to find the average energy of an oscillator. That means energy of each oscillator. This is the total energy, right? But I want to find the energy of each oscillator. So that can be represented by average energy of an oscillator. For a single oscillator, for each oscillator, what will be the energy? So total divided by number of oscillators, total energy divided by number of oscillator. So the average energy of the oscillator is given by E, which is equal to En divided by n. So what is this? En is the total energy and n is the number of oscillator. If I dividing this total by number of oscillator, I can get the energy of each oscillator, energy of each oscillator. So this I am considering equation number 1, right? So next, the possible energy values for the oscillators. So here n number of oscillators are there, right? So the possible energy values for the oscillators are, for the oscillators are, for the oscillators are. Okay, now listen carefully. The energy may be 0. Some oscillators will not have any energy. And then if n is equal to 1, it will have h nu. For example here, n is equal to 0, E is equal to 0. If n is equal to 1, then E is equal to h nu. And then 2h nu. And then 3h nu. Up to nh nu. Okay, so here I have given average energy, energy of each oscillator I have given, and what will be the possible energy values for the oscillators, that also I have given. It may have 0 energy, and some oscillators will have h nu energy, and some will have 2h nu energy, so it depends up to nh nu, right? And the next step, I am going to write the number of oscillator with these energies. Okay, so listen carefully. Let the number of oscillators with the above energies, that means with these energies. In the previous step, I have written what are the energies possible. So energies be, listen carefully, n naught. What is the meaning of n naught? N naught be the number of oscillators with energy 0, with energy 0, and then n1. What is this? Number of oscillators with energy E is equal to h nu. and then N2. N2 is the number of oscillators with the energy E is equal to 2h nu. Like that it is going on up to N suffix N. N suffix N. So in the previous step, I have written what is the possible energy value of the oscillator. And the second step, how many number of oscillator with these energies. Okay, that is what I mentioned. So next step, what I'm going to write is, according to Maxwell's distribution formula, Maxwell's distribution formula, how this energies are distributed to number of oscillators. So n suffix n should be equal to n naught into exponential of minus n h nu divided by kt. So this equation is the max distribution formula. So how the energy is distributed to the number of oscillators. How the energy is distributed to number of the oscillators. So Nn is equal to n naught into exponential of minus nh nu divided by kt. So here Nn is the number of oscillators and n naught is the number of oscillators with the energy 0 and exponential of minus n is the that is quantum number and h is the Planck's constant, nu is the frequency of the radiation and k is the Boltzmann constant and T is the temperature, right? So now I'm considering this one as equation number 2. So next step, I'm going to find n1, n2, everything. So how I am going to do? Now listen, where, okay, if I'm keeping n is equal to 1, okay, so if n is equal to 1, n becomes 1. So n1 into n0 exponential of n is equal to 1 I said. Okay, so first step is n is equal to 1. So now exponential of minus h nu divided by kt. Right? Same thing I'm going to find if n is equal to 2. How can I write? N2 is equal to n0, okay, exponential of, here n is equal to 2. So 2h nu divided by kt. Right? Next I can able to write n is equal to 3. If n is equal to 3, how can I write? N3 is equal to n0 into exponential of minus 3h nu divided by kt. So in this way I can able to write. Okay, so n1, n2, n3. Okay, so now the next step we are going to find the total number of oscillators. Okay, so what is that? Listen carefully. As capital N represents the total number of oscillators. Total number of oscillators. Total number of oscillators. So how can we write the total number? Some oscillators will have energy 0. Some oscillators will have the energy h nu and some oscillators will have the energy 2h nu, like that keep on it is continuing up to nn. So already in the previous step we have discussed what is the value of n0, n1, n2, everything. So n0 as such we can write, and then n1 value is nothing but n0 into exponential of minus h nu divided by kt. Right? And what about the second step? N2 is equal to same n0 exponential of minus 2h nu divided by kt, and so on and so on. Right? So now the next step, here you see the common term is n0 in all the terms. So I am going to take the n0 outside. So within the bracket what will be remaining here? 1 should be there. So the first term becomes 1, and then here exponential of minus h nu divided by kt, right? And plus already n0 over, so h exponential of minus 2h nu divided by kt. Okay, divided by kt. So next step what I am going to do is, to solve this I am going to consider, let x is equal to exponential of minus h nu divided by kt, minus h nu divided by kt. So now substitute this x value here. So n is equal to n naught into 1 plus, see this term, it is considered it as x. So x plus, and then here mine 2 is there, so it will become x square. So like that it is keep on going. Okay, so to remove this, that means to solve this bracket, I'm going to apply the binomial expansion. So from binomial expansion, from binomial expansion, what is the binomial expansion? 1 plus x square and so on should be equal to 1 by 1 minus x. So this is the binomial expansion. So for this bracket, I am going to substitute the value of 1 by 1 minus x. 1 by 1 minus x. So now the step is n is equal to n naught into 1 by 1 minus x. Okay, so that I can able to write n naught divided by 1 minus x. So this I am considering equation number 3. So what the equation number 3 gives? It gives the number of oscillators. The total number of oscillators n is equal to n naught divided by 1 minus x. Okay, let it be. The next step, I'm going to find the energy also. So the next step is, as there are n naught oscillators with energy E naught, listen carefully, as there are n naught oscillators with energy, n naught oscillators with energy E naught. In same way, we can write N1 oscillators with energy E1, right? And then N2 oscillators with energy E2. Like that, we can able to extend. The total energy will be, the total energy will be. So how can I write the total energy? So in the first equation, we have represented energy of each oscillator should be equal to total energy divided by number of oscillators. So what I mentioned here, total energy. So to find the total energy, okay, to find the total energy, this n should multiply here. That is energy of each oscillator into number of oscillators. Okay, so I can total energy will be, total energy will be E into N. Okay, what is this E? Energy of each oscillator, and N is the number of the oscillator. So how can I write energy E naught into N naught? Okay, and then energy E1 into N1. The same thing I am just expanding. Okay, and then energy E2 and N2 and so on and so on. So the total energy will be written like this. To find the total energy, E should be multiplied with this N. E represents the energy of each oscillator and N represents the number of oscillators. Okay, so now I hope you understand this step. So now I'm going to substitute the value. So energy 0, then the oscillators will be considered as 0, right? And then next step, E1 N1. So what is the E1 formula? Already we know that E is equal to H nu. Okay, so E1 means 1 H nu. So instead of E1 I can write H nu, and then N1 value just now we have discussed in the previous steps. So N1 is nothing but N naught exponential of minus H nu divided by KT, right? And the next step is E2. What is E2? If you keep 2 here, then we will get 2H nu. So 2H nu, okay, N naught exponential of minus 2H nu divided by KT and so on. And so on, right? So I just substituted the value of E and N. Okay, and then here the common terms I am trying to take outside. So what is the common terms you see? So here N naught H nu exponential of minus H nu divided by KT. So this is the common term in the second and third terms. So if I remove this, if I take outside, the first term become 1 plus. Okay, and then here what will be existing, you see, 2 into exponential of minus h nu by kt. Already one h nu by kt I have taken outside. The instead of 2, okay, one I have taken outside. So another one will be remaining inside. And then keep on it is going. Right. So the next step to solve this, I am going to consider the same. Let x is equal to exponential of minus h nu by kt, minus h nu divided by kt. So here I am going to substitute exponential of minus h nu by kt is equal to x. So what is the next step? So n naught h nu. Okay, instead of exponential of minus h nu by kt, I am going to write x. Okay, and then inside it will be 1 plus 2x. 1 plus 2x. Actually, if you extend, then it will become 3x square. Like that, it will go off. Okay, so again, I am going to apply the binomial expansion to solve this bracket. So now, from binomial expansion, for this expansion, the value will be 1 plus 2x plus 3x square and so on should be equal to 1 divided by 1 minus x whole square. 1 divided by 1 minus x whole square. So substitute here. So what will be there? En is equal to n naught h nu x. Within the bracket, we will get 1 by 1 minus x square, right? So 1 by 1 minus x square, right? So now this is En value. So this I am considering equation number 4. Okay. So now what is equation for En? Okay, it is the En. Okay, so this En is nothing but the total energy. The total energy. Okay, this is what we have discussed in the first equation. Okay, so now I'm going to substitute this equation 4 and equation 3 in equation 1. So what is the equation 3? That also let us see once again. See, this is equation 3. Equation 3 represents total number of oscillators. And then what is that equation 1? So this is equation 1. So energy of each oscillator should be equal to En by n. So now En will be given by equation 4 and n should be given by equation number 3. So now I am going to substitute in this equation 1. So let us substitute the values here. Okay, substitute equation 3 which gives capital N and equation 4 which gives the total energy of the oscillator in equation 1. So as we know well, equation 1 is E is equal to En by n. En value is n naught h nu x divided by 1 minus x whole square, right? Divided by n value from equation 3. So which is nothing but n naught divided by 1 minus x. 1 minus x. Right? Now you see n naught will be cancelled. 1 minus x and 1 minus x will be cancelled. So what will be remaining? H nu x divided by 1 minus x. Okay, h nu x divided by 1 minus x. So here I am going to do small modification. H nu x divided by, I am going to divide this two term by x. So how can I write now? Okay, this x only. 1 minute. This x I am going to take down. So how can I write? 1 by x minus x by x. So it will become 1. So how can I write now? H nu divided by 1 minus x minus 1. 1 minus x minus 1. Okay, so now I am going to substitute the value of x. Already we have substituted the value for x. So that value I am going to substitute here. So what is the value now? So E is equal to, okay, h nu divided by 1 by, what is the x value? Exponential of minus h nu divided by kt, okay, minus 1. right? Minus 1. So here the exponential term with the negative sign. If it goes up, okay, it will become positive. So how can I write? H nu divided by exponential of h nu by kt minus 1. H nu by kt minus 1. So this is the energy of each oscillator. Energy of each oscillator. So for this I can give equation number 5. Equation number 5, right? So now we calculated the energy of each oscillator. Energy of each oscillator. The next step what we are going to discuss is within certain wavelength range. Okay, not for all the wavelengths we are going to find. We are going to find within some wavelength range. Okay, so for example, the wavelength ranges from lambda and lambda plus d lambda. Okay, listen carefully. I am not going to find the energy of oscillator for the whole, okay, with a certain energy range, For example, if lambda is equal to 500 nanometer means, okay, and then with the plus d lambda. So lambda plus d lambda will be equal to 500 plus 200. Just for example, 200 nanometer. So totally it will be 700 nanometer. So for example, here the 500 nanometer will be there, and after some wavelengths it will be 700 nanometer. So within this wavelength range, what is the total number of oscillators present? Listen carefully. Within the range of the wavelength, how many number of oscillators present per unit volume? Per unit volume. So how can I write? The number of oscillators, the number of oscillators per unit volume, the number of oscillators per unit volume in wavelength range. This is what I mentioned. Wavelength range lambda and lambda plus d lambda is given by lambda and d lambda is given by, okay, so this is number of oscillators only. So number of oscillator means n, okay, which is equal to 8 pi by lambda power 4 into d lambda. 8 pi by lambda power 4 into d lambda. Okay, so within the wavelength range, so these many number of oscillators per unit volume present. Okay, so now the same thing, the same explanation we have to take for the energy also. So this is number of oscillators, n I finished. The next step is the energy per unit volume. The energy per unit volume, the energy per unit volume in the same wavelength range. Okay, in the wavelength range, in the wavelength range, lambda and lambda plus d lambda is given by. Listen carefully, we are talking about the energy. Okay, so energy per unit volume. So energy is represented by within the range. That's what it is represented by E lambda d lambda. So what is this represents? The energy per unit volume within the range of lambda and lambda plus d lambda, which should be equal to. So how can we find the energy? Energy can be found by number of oscillators, the same first equation only, number of oscillators into energy of each oscillator. Okay, so energy of each oscillator, energy of each oscillator. Okay, so this I am considering equation number 6. Okay, so listen, number of oscillators within the energy range is given by equation 6. Okay, and the energy of each oscillator is given by equation number 5. So now 5 and 6 should be substituted here to find energy per unit volume. Okay, so now I am going to substitute equation 5 and 6. Okay, so now substitute equation 5 and 6 in above equation. in above equation. So what is the above equation? E lambda d lambda. What it represents? The energy per unit volume within the energy range should be equal to number of oscillators from equation 6. So what is the equation 6? 8 pi by lambda power 4 into d lambda into energy of each oscillator, that is we are going to get from equation number 6. So what is the equation number 5. So here h nu divided by exponential of h nu divided by kt minus 1 divided by kt minus 1. Okay, so as we know well, the relation c is equal to nu lambda. C is equal to nu lambda. C is the velocity of light and nu is the frequency and lambda is the wavelength. So from this, nu is equal to, how can we write nu? C by lambda. So here I am going to substitute this value. So how can I substitute? 8 pi divided by lambda power 4 into d lambda into h c by lambda whole divided by exponential of h nu divided by kt minus 1. Right? Here one lambda and here one lambda. So both will be added together. So how can I write? 8 pi h c divided by lambda power 5. Okay, into 1 divided by exponential of h nu divided by kt minus 1 into d lambda. I am writing here into d lambda. So which should be equal to e lambda into d lambda. So this d lambda and d lambda will be cancelled. Okay, so that the remaining part is e lambda is equal to 8 pi hc divided by lambda power 5 into 1 divided by exponential of h nu divided by kt minus 1. So this is the required equation. That is, this is the Planck's radiation formula to explain the heat radiation, Okay, so this expression represents Planck's radiation formula. Planck's radiation formula. Radiation formula, right? So this is what the expected one. So E lambda is equal to 8 by hc divided by lambda power 5 into 1 by exponential of h nu by kt minus 1. Here 8 is the numerical number, pi is the constant, h is the Planck's constant, c is the velocity of light, and lambda is the wavelength of the radiation incident on that, and then exponential of again the same, h is Planck's constant, nu is the frequency, k is the Boltzmann constant, T is the temperature. So this is the Planck's radiation formula. Okay, so please go through that. If you have any doubt, you can ask in the comment box. So thank you everyone.